Grilling is a nice way to enjoy a sunny day. However, most people can only grill in their backyards. This is because most grills are big and heavy, making it hard to move around and fit into the back of cars. A more portable grill would allow people to take the grill wherever they wanted. They can now take their grill to the beach, camping, or kayaking. We set out to design a grill that would meet this demand. Constraints were created to ensure that the final product would meet the demands of the consumer. First, the grill must be small, roughly 40 by 40 centimeters and no more than waist high. The grill must collapse completely flat and be extended in a single easy motion. Finally, the grill must be lightweight, weighing no more than about 5 pounds. In order to create our design, each of us brainstormed several solutions. Of these solutions, 2 were further developed into working CAD models. The CAD models allowed us to visualize how the products would be used and how they could possibly be manufactured. The first design used the motion of the sides to drive the legs downwards using crank sliders and connecting rods. The second design used a central input to pull all 4 walls up and extend the legs. Since the second design proved to be lighter, easier to use, and easier to manufacture, it was chosen as our final design. The mechanism used to raise and lower the walls consists of a double slider and a crank slider. The double slider consists of joints A and B, linked together by link 4. Vertical input from joint A is transformed into horizontal motion in joint B. The crank slider mechanism consists of joints B, C, and D, which are connected by links 3 and 2 respectively. Linear motion of the slider joint B is transformed into rotation of link 2, in this case the wall and legs. The goal of the kinematic analysis is to determine the linear and angular displacement of the joints and links. The 2 parameters to be solved for here is delta A, which is the vertical distance that the handle must be pulled up, and delta B, which is the horizontal displacement of the slider. Using the kinematic analysis techniques shown here, the displacement of B is found to be 10.8 millimeters. Once the horizontal displacement of slider B is found, the vertical displacement of A can be found to be 49.16 millimeters. The chosen material for the grill walls was 24 gauge sheet steel. This material offers good heat resistance but is thin enough to remain light. The links were chosen to be made out of aluminum due to its ease of manufacturing. However, for a production grill, it would be advisable to use a more heat resistant material. Once the materials were obtained, they needed to be manufactured into their final parts. The links were designed to be manufactured using a milling machine, but since the machine shop was closed, they had to be done on a bandsaw and hand tools. In order to create the holes, first each part was center punched and then carried over to the drill press to drill each hole. The steel walls were intended to be cut using a large bandsaw, but were instead cut using tin snips. Parts were held together using 632 threads, allowing us to use the same tap for each component. Before assembly, parts were sanded and filed down to ensure there were no sharp burrs. Since a lot of the components could not be manufactured without a milling machine, the final prototype was never constructed. However, a detailed SolidWorks model was created to demonstrate how effectively we met the initial constraints. To use the grill, pull up on the central eye bolt. Once the grill is raised into position, lower the bottom plate onto the 4 pins. This locks the grill into its operational position. Finally, place your charcoal onto the bottom plate and then put the grate on top of the grill. Using SolidWorks mass evaluation tools, the weight of the grill was found to be about 4 pounds. The height of the grill, once extended, came out to be 500 millimeters. The 40 by 40 centimeter grilling surface is capable of grilling 3 to 4 burger patties simultaneously, which we believe to be satisfactory in a camping situation. To improve this design, more heat-resistant materials could be used for the links. A removable surface could be placed where the charcoal sits to make the grill easier to clean. Access to better manufacturing techniques could allow the links to be made more efficiently. In addition, the sliding mechanism could be improved upon with access to better materials.